at another example. Sketch the graph of y equals to negative modulus of 2x plus 3 for a given range of values of x. So we start off by drawing the line y equals to 2x plus 3. We will first consider intersection with the y-axis. When x is 0, y is 3. Intersection with the x-axis, y equals to 0. X equals to minus 1.5. And given this range of values of x, we will consider also the two endpoints when x equals to minus 3 and x equals to 1. When x is minus 3, you got minus 6 plus 3 is minus 3. When x is equal to 1, you have y equals to 5. So we draw a dotted line to show the line y equals to 2x plus 3. So this is a dotted line that represents the line y equals to 2x plus 3. Now we put on the modulo sign. That means y equals to modulus of 2x plus 3. So we know what's the effect. This part that is positive will remain unchanged. This part will be reflected above the x-axis. So this point minus 3 will go to 3. So you get this V-shaped graph. Right? You get this V-shape. Now that's not the end, because there's a negative sign in front of the modulus. So now we put a negative sign. The effect of this negative sign is that every point, okay, is now reflected about the x-axis. Hence, we get an inverted V-shaped graph. Okay, we have an inverted V-shaped graph like this. So this is the final answer, okay, for y equals to negative modulus of 2x plus 3. Now let's look at part A. State the corresponding range of values of y. Okay, that means for this given range of values of x, what is the extent of values of y? As you can see from this inverted V shape, the values of y is from the lowest point here, which is minus 5. Okay, yeah, I forgot to indicate the endpoint. 1 minus 5, and then this point is minus 3 minus 3. Okay, so the lowest point is minus 5, and the highest point is 0. So for part A, the lowest value is minus 5 and the greatest value is 0. So the range of values of y is from minus 5 to 0. Part B, find the range of values of x. find the range of values of x for which y is more than negative 1. This is the line y equals to negative 1. Which part of the graph is more than negative 1? Okay, if I were to highlight, you can see that this is the graph. This is the portion of the graph that is more than negative 1. And the range of values of x refer to this range. Okay? Refer to this range of values of x. That is, the graph is more than negative 1. Now, of course, because I drew this graph quite accurately, you can actually read the 2 points, minus 2 and minus 1. But if your sketch is not drawn to scale, you may not be able to read these 2 points. So you need to compute, okay, the 2 values. Okay, you can compute it by substituting y equals to negative 1 to find these 2 values of x. So I put in y equals to negative 1 into this function, into this original function to find the 2 values of x. Okay, cancel the minus sign. So now I remove the modulus. I got 2x plus 3 equals to 1, or 2x plus 3 equals to minus 1. So I have 2x equals to minus 2, or 2x equals to minus 4. I got x equals to minus 1, or x equals to minus 2. So now, this is minus 1 and this is minus 2. So for the range of values of x for which the graph is above minus 1, x is from negative 2 to negative 1. There's no equality sign. Okay, so it's just from minus 2 to minus 1.